Very good afternoon to you. It's Dean from maverickstar Observatory. Guys, I feel we need to check our facts a little bit on this experiment and, what we've been witnessing up to this day, because if we really are 10 months away from a big event taking place on our Earth, then we really need to get serious about getting ready for that event. What do we know so far? We know that since the 1900s, over 120 years ago, that the magnetic North Pole started to migrate. This has been accepted by a lot of the bigger organisations. NASA accept it, NOAA accept it, and the European Space Agency accept it. We know that the European Space Agency set up a space mission to monitor from low Earth orbit, the magnetism and field of our Earth over the last few years, over the last decade. We've not been allowed over level 2 data from Swarm mission at the European Space Agency for some reason. I do understand that there is a military aspect attached to that, and I believe it's to do with fighter jets using the magnetic maps so that they can fly lower to the ground. So, if that's part of the classified information they're not releasing to the public, we can say that that is almost understandable. We don't know a lot of the details with relationship to, other than what they've allowed us to have, we don't know really where we stand with the information that we've not got our hands on. There is another element to all this, is that we still, to this day, do not know what mechanisms are setting up the dynamo, if you want to call that, in the interior of our Earth that generates the dipoles on our planet, north and south, and the magnetosphere in turn, which is our protective shield from cosmic rays. What we do know is that it has weakened around 15 to 20%, maybe a little bit more. Again, this is something that they are not sharing with us. This is one of the reasons why we put magnetometers in different various locations around the world, and by doing a mean calculation on those different areas, we worked it out to be around about 50 microteslas in strength. And when we do an Earth Alpha update, we put the latest coordinates of the magnetic North Pole on our website. It's under Earth Alpha at a glance, and you can see where on the 17th, where we've downloaded all the data over the month on the SD card onto Excel and processed it into a very simple chart so that you can quickly at a glance see where we're going. We collect over 300,000 entries every month because we're monitoring it every 3 seconds there at the observatory. The magnetometers that we've got out in the field in different places of the world, they're recording every 15 minutes, and when we get the data sent from one of our superstars, either Australia, Canada or Arizona, we put it up on the website. We did have a superstar in Hong Kong, but they've recently moved. But from the point of time when they started monitoring it to the point where they ended monitoring it, all that data is on the website as well. We've had it in a few other locations like Southern California as well, as you can see if you go onto the website. We've got some problems there. I really want to hope that this experiment is wrong, because if it's right, we're on that doorstep already. We've got 10 months before we reach the vicinity of 40 degrees. This experiment shows that once it surpasses 40 degrees, the dipoles of our planet will leave the strong magnetic field lines. And it's whilst they're in those strong magnetic field lines that the pole is only able to migrate over distance very slow. Because this experiment shows us that once the 40 degree mark is surpassed, it enters the weak field lines and then accelerates very quickly. You could say that from that 40 degree mark, our Earth goes into the transition of a pole reversal. There's lots of things we don't know. I have watched documentaries. I've invested 10 years into this, and I've watched lots of documentaries created by some really great organisations on the magnetic pole reversals. And I do remember some scientists, I think in one of the territories of Spain, was monitoring lava flow. And as we know, that whatever magnetic field or polarity the field's in, whether it's a north or south, it is recorded in rocks. When it solidifies, it traps the alignment of those materials in the direction of whatever pole it was at that point. You know, it's a similar thing to when we study, you know, at the mid-Atlantic Ocean ridge, the solidified lava. That's how we know we've had, you know, many pole reversals on our planet. And, you know, likewise, they have trapped in the rock, the magnetite, in the direction of the current pole. It reverses. It's clear to me that it reverses 180 degrees. We have had what is called excursions over, you know, the period of the last magnetic pole reversal. Excursions are very short-term processes. They appear as though the poles are reversing, or they may reverse, but temporarily they will go back to the original pole. It will not be a full transition from north to south for a long period of time. Those are the things that we're interested in, and we're interested in them mainly because we're 500,000 years overdue a completed reversal. Now, even if it was an excursion, we know what to expect. During excursions, the magnetosphere collapses to around 5 to 10%, and during that point in time, you know, our upper atmosphere is subject at that point to erosion from radiation coming off the sun, as well as radiation entering our solar system from other galaxies, including our own. So, you know, it's critical that whatever happens, whether this is a completed reversal or an excursion, that period of time where we have a very low magnetosphere strength protecting us is only for a short period of time. If it's prolonged, we stand the chance of, you know, what a term now is, NASA's called it, sputtering, which is an erosion of our upper atmosphere. And it's the upper atmosphere as well as the magnetosphere that protects us from the harmful cosmic rays. First of all, the magnetosphere pushes away, in a very similar way the heliosphere does, cosmic rays from our solar system. The magnetosphere pushes it away, that cosmic radiation, from our Earth. If it gets through the magnetosphere, we have the upper atmosphere to protect us. When these cosmic particles go through the magnetosphere, which protects us, our primary shield, and collide with molecules in our upper atmosphere, they shatter those molecules, and we end up with byproducts or subatomic particles like muons. That's also one of the tools we have in our kit to monitor what's going on. We've got muon detectors in Australia, we've got muon detectors in Canada, we also have them here in the UK. So we're covering everything we possibly can at the observatory. First of all, we're tracking the dipole, we're measuring the magnetosphere strength, and we're monitoring the radiation inbound. All three very important aspects of what times we're in right now with our Earth going through this reversal. The main thing is, have we squared away everything accurately as we possibly could have? And over the last few days, based on some of the comments we had, you know, I began to question, you know, some of the results. But the chances are finding an experiment that replicates what we are seeing right now is extremely rare. You know, we knew from this experiment that we conducted this experiment 6 years ago, and some of the questions that was asked recently in the comment section was questions we was answering 6 years ago. It would be, if this was not accurate, this experiment, it would be extremely rare to find an experiment like this that would replicate what we've seen so far. That is, we know whatever's happening in the core of our Earth, that is exactly where our magnetosphere is being generated. We know that it has rotated at least 40 degrees. If it is happening inside the interior of our Earth, it is rotated. I have doubts on that, and I'll share them with you. We've also conducted other experiments using various materials that have magnetic ability. Namely, one, I don't know if you remember when we got an neodymium magnet and we introduced it to a fire and kept it in that heat for a long period of time. When we retrieved it, the magnetic ability of that material was gone, and it was no longer a magnet. So when we put it by the compass, it didn't affect it. Now, my problem is, if we're to believe that we have an internal core which is molten enough to melt iron and all the other materials in the core, how can it sustain its magnetic ability? And I think that leaves questions, you know, whether whether our core is able, first of all, to hold on to anything magnetic in its core, in its process. And, you know, the reason why I say that is because of the heat factor. It seems to me that magnetic material does not like heat, and if heat is introduced to that magnetic material, it very quickly loses it. So, you know, I mean, this is questions that, you know, our scientists have been trying to figure out. The problem is that these things are supposedly happening deep beneath the core, beneath our feet, well through the crust and into the core, and we are only operating on best guess scenarios. What we do know to this date is that there is a magnetosphere that can be affected to the point where it can create pole reversals. We've seen that in the evidence that we've gathered, so we know that that's fact. We know that if we lose the magnetosphere, and, you know, this is a possibility, it happened to our neighbouring planet Mars, then the upper atmosphere over a prolonged period of time will be eroded away, and it won't be long before the water on the planet is also eroded away. It will also mean that we will have no protection from increased cardiac arrhythmia and cancer. So we want to really hope that, you know, this event, if it is going to happen within a 10-month period of time, if it's going to start at that point, we want to hope that the reversal happens very quickly. Now, some of the research I've seen with regards to excursions, it seems that when the pole actually reversed, it did so within under a month. And then obviously, you know, like we see in this experiment, once it goes past 40 degrees, it seems to migrate very quickly in the weak field lines around another 100 degrees, and then slowly settles down to a fixed position in its reverse poles. So north goes to south. Again, like we've seen, it arrive at the 40 degrees mark over 120 years. It might take another 120 years after the 100 degrees through the weak field lines has started. So, but if that is the case, we would expect at least 80% of the magnetosphere at that point to come back up during that period of time. I think I'll run the experiment while I'm talking about this to you. You know, a few weeks ago I showed you some lightning coming out of the ground, and I said we really needed to talk about this, but, you know, we really try and focus on just the magnetic reversal on this channel, but there is a lot of science, I think, that needs to be better understood. And, you know, just to deviate a little bit from the pole reversal, I'll leave the experiment running there so you can see what happens when it goes past 40 degrees, how it enters the weak field lines and then goes almost to south and then slows down again, and then the experiment is repeated. What else am I talking about? I'm talking about gravity. Now, I know that there's a lot of people that believe that we've already, in some secret department, discovered how to create anti-gravity. I'm fully aware of some of the aircraft that has been suggested that runs on a type of anti-gravity. I'm talking about the TR-3B, which is supposed to be powered by a liquid mercury plasma propulsion system. I think myself, it doesn't exist. I know that there will be people saying it does, and we've managed to overcome gravity. If that was the case, if we'd managed to overcome gravity, do you know what we would have also have done? We would have managed to reproduce free energy at that point. I guarantee you now. And I don't think we have got there yet. And you know, I really think it's a shame that we have invested more as a species in modern iPhones than we ever have done, going back to trying to explain that question, what is gravity? Because since Isaac Newton worked out the force of gravity, that being 9.8 meters per second, we've done very little work on what gravity actually is. Is it a particle? Is it a graviton particle? Is it a frequency? We know it is electromagnetic, that is for sure, but what is it? You know, and can we reproduce it? Can we block out that effect? Now, I've heard some scientists, they really don't like to talk about it, what gravity is. Some say it's a particle smaller than a photon. Well, you know, can we recreate gravitons? Or can we recreate something that blocks out gravitons? You know, I want to show you another experiment, perhaps over in the next few weeks. It involves just an ordinary balloon. You know, you've probably done that little thing where you've rubbed it on silk material or woolen material like your jumper, and you've been able to stick the balloon to the wall. I started to really look into a few years ago, well, it's been a lot, probably longer than what, you know, we've been studying the magnetic field of this earth, probably going back over a decade. I started to look into all the possibilities that people had said that was, you know, real in terms of anti-gravity. I'd built those lifters, those cute little things that don't have any signs of propulsion yet. They are producing like an iron wind, which creates lift on a very lightweight bolster wood triangle. You've probably seen them, using around 25,000 volts. I had it tethered down. I built quite a large one. I was using the power supply from a computer monitor at the time. I think it was in the range of about 25,000 volts. And, you know, it was interesting to just see this thing floating above the table, which was tethered with little cotton string, you know, sellotaping it down to the surface to stop it, you know, hitting the ceiling. But, you know, to see something with no moving parts fly, the only thing that's close to that has no real moving parts is a rocket engine. That's if you exclude the turbo that runs the fuel through the engine nozzle. You know, other than that, we don't really see too many things that have no moving parts, yet produces a lot of thrust or propulsion. And you know, that came from a guy called Townsend Brown. I think it was back in the 40s or 50s. This was a guy that was doing experiments, some would classify it as anti-gravitics, but his work was classified by the Americans, Air Force, and basically we wouldn't have been having those lifter experiments if it weren't for him. But some of the experiments he was conducting was working with capacitors. I want to explain to you why that is of interest, because going back to that balloon, when you rub it, some say you put a static charge on it, and the static charge is proportionate to the surface area of the balloon. And if you've got a very large balloon, then you can obviously add more static charge to it. But the main thing is that you are technically giving the balloon a gravity. Now people wonder, how the hell on earth are we able to stay on it when it is spinning round at 1,000 miles an hour? How come everything isn't flying off? Well, the simple explanation for that is it's obviously got a gravity. Now, I will speculate here, because, you know, we could prove this simply. I'll explain how. I will speculate that, like the balloon has a charge, overall charge over its surface area, and it's limited to its surface area, then you're able to give it, you know, a gravity. And I started to experiment with that balloon, I thought, well, okay, if we narrow down everything within our universe to simple things, what would they be? Well, it would be conductive materials and non-conductive materials, or, as would probably better be explained as, conductors and dielectrics. And of course, you know, if we go back to Townsend Brown's work, in the capacitors that he was charging up with, exotic voltages, you know, I think in the millions of volts, what he found during some of these experiments was the actual table that the capacitor was bolted to was actually trying to, you know, lift off. And I think it was described one day that the table did actually hit the ceiling in the hangar roof. So if there is any truth in this, first of all, it does ring right, because capacitors, if you pull them apart, they've got dielectric and conductive materials in there. Well, that's just the nature of them. But more so, they have been rolled up. Their surface area of the capacitor has been rolled up, which means, you know, just like the balloon, if it's a bigger balloon, obviously it holds twice the amount of surface area or gravity than what a smaller balloon does. Just think of this as Earth, 9.8 meters per second force of gravity. The moon's a lot smaller, has a lot smaller surface area, so that's why, you know, we have 1.5 meters per square meter. So, you know, I found that the charge of a balloon would attract silver file, which is a conductive material. It would also attract, at the time, sweet wrappers, which were made of plastic, so they're dielectric, and it would attract both of them, and that fits what we would need to, you know, gravity needs to attract both of those. It doesn't it's regardless of whether it's in the form of a car or, you know, a piece of paper or whatever. Nothing leaves our Earth because everything is held on the Earth by the gravity. The gravity doesn't discriminate with anything on our planet, otherwise it simply wouldn't be here. And this is a universal law because it's the same throughout everywhere, as Isaac Newton found out, you know, back in the 1800s, I think it was. So, you know, we have invested, in a nutshell, we have invested a considerable amount of time in iPhones and nothing in one of the very natural forces in the universe, let alone on our planet. Why is that the case? Why have we not invested more into working out what's going on in the interior of our core? Why have we not worked out, you know, how to overcome or block gravity from objects? I came up with an idea, and I don't know whether we'll ever have the money here in the observatory to actually put this to the test, and I don't mind if somebody else you know, uses the theory or looks into it if they've got the funds to do it. But I believe, like the capacitor and like Townsend T. Brown's experiments, if we laminate dielectric and conductive materials into tiles where we have thousands of laminations over a square meter tile, I believe eventually when we charge up that as a capacitor, it will eventually block out the force of gravity, and whatever is placed over that tile, if not the tile does it itself, levitates. Whatever we place over that tile will be shielded from the force of gravity. Just want to say something else. You know, the way we generate electricity right now, let me tell you something. Just ask a physicist where that electricity is coming from to start with. We must be in an environment saturated with electricity or charge in order for a motor or a generator to just keep sucking these things out and producing them in a form of you know, mechanical movements. When we use the generator to generate electricity, we use that electricity in a mechanical way to run our electrical appliances. But we must be in a sea of this charge, because as some people thought, and tests were done, they said, well, was the electrons or the electricity coming from the actual copper winding in the motor? Well, we know it's not the case. The copper winding never reduces, no matter how much electricity it just the generator produces, the copper winding, is not where the electricity is coming from, and it's certainly not in the magnets that run round the copper windings. So if it's not from the magnets and it's not from the copper, then first of all, what is it actually, a motor or a generator? Is it just, to use an analogy, is it just a electric pump, like a water pump would be, to pump water from one place to the next? Is the generator doing the same thing? And then if that's the question, where is the electricity actually coming from? It's got to be in the abundance of that electricity pump, or let's call it what it is, an electrical generator. It's got to be in the vicinity, and it's going to be in abundance. I think all this we are doing, and it may come out in maybe 10 years, 20 years, all these theories, that this what I'm supposing it might come out. I believe the electricity which we're tapping into, which the generators are sucking out of the environment around us, I believe it's the electrical charge that is responsible for gravity on our planet. And I wouldn't be surprised if we find out that the magnetic anomaly, which is supposed to be generated in the core of the Earth via the dynamo that creates our dipoles and our magnetosphere, I wouldn't be surprised if it turns out to be gravity, and all this we are measuring over the northern and southern hemispheres are the two polarities of that charge, of the gravity. Because like I showed you in that experiment with the plasma ball, when we slow the plasma down using a high powered magnet in the vicinity of the Tesla coil, guess what we experience? We experience a slower moving plasma over the coil, but more so we see that it is divided, just like the magnetic viewer over a magnet, between a north and a south, and in between there's an equatorial region where the weak field lines are. So I think we've got lots of work to do. I started off this video asking the question, how accurate is this experiment that we're watching with regards to possibly the events that are going to take place? I think it's well up there in the 90%. I don't think that we stumbled on this experiment by coincidence. The very fact and nature. I mean, look where it's stopped right now. I don't know whether the video will be in sync, but at some point it stops just before north. I've switched the power off. Look at the position of the magnet. We know that as the magnet is in that position, there is a north on the top, a south on the bottom, and the alignment is the equatorial region of the magnet where the weak field lines are. When you stop it at 3 o'clock, the magnet, you can see that the needle is just about to go into the 40-degree mark. If we just go a little bit beyond that, it reverses, goes through the weak field lines, and goes a complete reversal, or almost. So, guys, it is, I suppose, down to you how you feel about all this. I've explained over the last few years everything I know about pole reversals, and we've done experiments on a lot of various things to do with magnetism, and we've got this now experiment here which we're showing you again. So I suppose it's down to you at this point on knowing the information that we've relayed to you, what it is you intend to do about it. Because I suppose in some respects, without you not knowing there was a train coming and you were standing on the track, now there's a train coming and you know that you are on that track and it is arriving. It could be arriving in 10 months' time. Have you squared away a few things that can help you during this period of time? Look, worst case scenario, the magnetosphere collapses, and that is the last reversal this planet sees, just like Mars. Best case scenario, the reversal takes place very quickly, hopefully within the space of a month, if it starts to linger and take longer, and the magnetosphere goes down for a long period of time, you know, we're going to see cancer rates exponentially increase, and then cardiac arrhythmias likewise. And it won't be just affecting the human population, it will affect all biodiversity, all of the biodiversity on our planet. You know, there are a couple of fundamental things that keep our world inhabitable for us. Firstly, it's the magnetosphere. Secondly, we have water on our planet, and because we're air-breathing mammals, you know, we've got oxygen in the atmosphere. Right now, we've got an abundance of water that is not at threat. We also have 20% reservoir of oxygen in our atmosphere. That is not at threat. But one of the things that sustains life is really at threat, and that is our magnetosphere. Guys, we would like to, you know, be with you as time goes on. I'm hoping that in the next several months that we were going to start to see, as we get closer and closer to that 40-degree mark, an uptick in possibly the migration speed over distance, and we should be seeing something take place with those monitors, those magnetometers that we've got in the field, and likewise with the muon detectors that we've got in the field. I very much doubt, with what's going on with Ukraine and Russia at the moment, we are ever going to get now a magnetometer or a muon detector into Russia, because, well, let's face it, they even hold up these days an invisible sign and they're classed as protesters and they get arrested for it. So can you imagine if they was collecting data for a British observatory, what could possibly happen to them? They'd probably end up in jail, wouldn't they? But what we can do is probably get one in a country neighbouring Russia, maybe even the Ukraine, I don't know, or one of those countries around there, maybe Finland, or, you know, one of the Uzbekistan, or you know, one of those regions as close to Russia as possible, and we could take some intensity readings there. But what we could do, and still, you know, I encourage anyone in Brazil to come forward, and South Africa as well. Let's get magnetometers in these regions and record the data from one of the lowest intensities on our planet, the South Atlantic anomaly, and let's see how much radiation is inbound in that region. Because I do know when the International Space Station flies over there, I believe some of the equipment has to be shut off, because that low intensity is extending well out into the orbit of the ISS. So, with having said all what I've said, guys, I hope you enjoyed the light talk about other things like gravity and things like that, and you know, we hope you got something out of the video. There's a link down there. Oh, by the way, I was right. You know, when I said 4,000 people would watch the video the other day and only a handful would put their hand in the pocket and chuck a bit of support our way, that was the case. But a huge thank you to those that did. And you know what, guys, I would love to encourage you to be one of our supporters. You know, there are nearly 4,000 people that watch these videos when they are uploaded onto YouTube. It would be amazing if we could just encourage a few more people to support this very important work for us here and you guys out there. You know, we've gone so far, it would be a shame for us not to be a little bit more braver and go a bit further. We've got 10 months probably. Now, more than ever, surely is a time to support us. Links down there if you want to. The only other thing to say is, I hope you enjoyed the video. Take care of your loved ones, as always. Bye for now.